Hey, Dr. J is back. We're going to finish chapter 5 today, or probably tomorrow. So just to be safe, I don't want to get you too excited. This is part 1 of 5.4, but we are going to definitely finish chapter 5 this week, and I'm going to post the test at the end of the week on Thursday. Okay, so modular systems. We're going to motivate this with a clock, because sometimes the math in this section is sometimes referred to as clock arithmetic. So I'm going to start right off with an example before I do any backstory. Suppose it is 1 o'clock. Don't worry about whether it's AM or PM right now. It could be either AM or PM. So suppose the clock says 1 o'clock. So we have a clock here, and we know that the clock reads 1 o'clock. So something like that. Okay, don't worry about whether it's AM or PM. We'll cover this next. What does the clock, or what time will the clock read after 190 hours? All right. So you have a clock, 190 hours. This hour hand is going to go around and around and around and around, and you could sit here and count, right? After 1 hour, it would be at 2, and 2 hours, it would be at 3. So 2 hours. After 1 hour, it would be at 2. After 3 hours, it would be at 4. After 4 hours, it would be at 5. 5 hours, 6 hours, 7 hours, 8 hours, 9 hours, 10 hours, 11 hours, and you're going to get really sick of doing this. You don't want to sit here and go all the way to 190. However, we're going to notice a pattern. Look, when you get to 12 hours later, every 12 hours, you're back at 1 o'clock again. Yeah, that's the way a clock works. You probably noticed this when you were, I don't know, 5, 6 years old, the first time you saw a clock and started learning about how the hands work on the clock. Maybe it was, first grade or something. And I know that many of you were curious little first graders, and you thought to yourself, oh, what happens if, I used to spend a lot of time, you can tell, staring at the clock. And you could count how long it would take to get to 190. But notice every 12 hours, you're back at 1 o'clock. So 12 sort of acts like 0. Yeah? It's like saying 1 o'clock plus 12 hours is still 1 o'clock. So the 1 is sort of acting like 0. When you add 12, it's like adding nothing. Okay? So before we actually go through the process of counting all the way to 190, we could think a little bit about how a clock works. Yeah. So after some investigation into clock behavior, we notice that 190 divided by 12 is equal to, what's 190 divided by 12? Don't use a calculator, because a calculator is going to give you a decimal, and that decimal is not going to help you at all. So you're going to have to do it like this. 190 divided by 12. Unless you have a calculator that does it the old-fashioned way. They do make calculators like that, but I don't think anybody has one. If you have one, that's great, though. 12 goes into 19 one time. 1 times 12 is 12. The remainder is 7. Bring down the 0. 12 goes into 70, 5 times. 5 times 12 is 60. And so the remainder is 10. So this is 15, remainder 10. Now remember what the 15 means. The 15 means 15 times 12. Yeah? Plus 10. That's what 190 means, and that's what the remainder of 10 means. The remainder of 10 means that you're going to go around the clock 15 times on the clock. So going back to my clock diagram, I don't know why I erased it. I put the 9 on the wrong side. So going back to my clock diagram, there we go. Going back to my clock diagram, if we started at 1 o'clock, by the way, we're only counting the hour hand anyway. So we're starting at 1 o'clock. The 15 would mean that it would go around and around and around and around and around 15 times. Yeah, so it would go around 15 times, 15 12-hour cycles. Those are called cycles. 15 cycles, plus an additional 10 hours. So I really only have to do 1 o'clock plus 10 hours, because these 15 cycles are going to act like 0. Yeah, because you're just going to end up right back at 1 o'clock again. And then you're going to add 10 hours to that. And so the clock will read 11 o'clock. Yeah. Now we won't know if it's AM or PM, because a 12-hour clock typically doesn't show you whether it's AM or PM. You have to know, is it daytime? Is it nighttime? When's the last time I looked at my clock? Most 12-hour clocks don't indicate AM or PM. We leave that up to the human being to look at the clock and then look outside and figure out what time of day it is before you decide whether it's AM or PM. Is it afternoon or is it before noon, or what's going on? Okay. We'll get to the AM or PM PM question in a minute. Thank you. Got a package. We buy everything on Amazon now, apparently. You're probably doing the same. So this is the motivating example for what we call clock arithmetic or modular arithmetic. So this is called modulo or modulus 12, abbreviated mod 12. Some people say modulo instead of modulus. It means the same thing. Everybody says it the same way. When we abbreviate it, we just say mod 12. So basically, in mod 12, 12 acts like 0. 24 acts like 0. 36 acts like 0. Any multiple of 12 acts like 0 in this arithmetic called mod 12. Now, let me explain what I mean when I say acts like. This is called a congruence. When something is behaving like a particular number, if it behaves like 5, we say it's congruent to 5. If it behaves like 0, if it has the same effect as 0, we say it's congruent modulo 12. So we say 12 is congruent. This is the symbol for congruence. So it's a 3-barred equal sign, is congruent to 0 mod 12. Okay. So let's ask a much simpler question. Suppose it's 1 o'clock. What time is it 13 hours later? Well, 13 acts like 1. It's congruent to 1 mod 12. Yeah. 14 is congruent to 2 mod 12. So if I were to say, it's 5 o'clock and it's 5 o'clock, what time is it going to be 14 hours later? Yeah. If it's 5 o'clock, 14 hours later, well, 14 acts like 2 modulo 12, and so you could simply add 2. So if it's 5 o'clock, 14 hours after 5 o'clock, you know it's going to be 7 o'clock. Because you don't have to add 14, you can just simply add 2. 15 is congruent to 3 mod 12. So 15 hours on a clock, you might as well just add 3 hours. Because these essentially mean the same thing on a clock. Okay. And I'm just going to say, et cetera, et cetera, et cetera. By the time you get to 24, I'm not going to do all the numbers in between. You can do the rest. 16, 17, 18, 19, et cetera, you're going to be back to 0 again. Just like a clock, this cycle would go around and around, and every time you hit a multiple of 12, it goes back to 0. Okay. So this is what we call congruence modulo 12. In general, we use n for a modulus and define congruence as follows. A is congruent to B mod n. So n is our modulus. In this example, our modulus was 12. I'm using the clock as the opening example, but we're going to certainly move on to some other moduluses. If and only if A minus B is a multiple or is divisible by n without a remainder. Or you could say with 0 remainder. Easy to demonstrate that over here. Look. So A is the left-hand side, B is the right-hand side, and then the modulus in my example is 12. So you can see A and B and mod n. Just to match this up here. So 12 minus 0. Is that divisible by 12? Of course it is. 12 minus 0 is 12. 13 minus 1. That's 12. Yeah. 14 minus 2. That's also 12. So if a minus b is divisible by n, then we say that a is congruent to b. Okay, let's try an example, actual example. Find the value that makes the congruence true. So blank, 90 is equal to blank mod 12. So we want a minus b to be divisible by n without a remainder. Okay. So how do we do that? Well, we do 90 divided by 12. You got to do it with long division. It's going to be 7 times. 84. Remainder 6. Yeah. So that means the remainder is 6. And you can easily check. This is A, this is B. Using this definition here, to check your answer, make sure that A minus B is divisible by 12. So what do we have? 90 minus 6 better be divisible by 12, otherwise something is wrong here with no remainder. So 90 minus 6 is 84. 84 is divisible by 12. Yes, it is. Yeah. 84 divided by 12 is equal to 7. No remainder. Be careful when you check your answer. Don't give me the check as the answer. The answer is over here. The answer is 6. I have had students do the problem, get the right answer, then come over here, check their answer, get 7, and then accidentally change their answer to 7. So the 7 is just checking that you do not get a remainder, that it is in fact divisible. All right. If you want to reference this back to what we were just doing a minute ago, that essentially means that 90 hours on a clock acts the same as 6 hours. All right. So if it's, I don't know, 3 o'clock in the afternoon, right? And you say, okay, what's it going to be 90 hours later? Well, it's going to be 6 o'clock. It's hard to tell whether it's going to be AM or PM or not. We'd have to figure that out later. In fact, later is now. So let's do example 2. Suppose it is 3 o'clock p.m. What time will it be in 150 hours? Okay. So this one's a little tougher. All right. Because I want to know whether it's going to be AM or PM in this particular question. So I'm asking specifically what time is it, AM or PM, not just what, number is the clock hand pointing to, which is what I was asking earlier. So if we want AM or PM, we need to use a 24-hour clock, like the military. Yeah, military time. So the way military time works is you have 24, and then you got 12. 24 acts like 0. Yeah. 12 is halfway through the day. Then you got 6 over here. You got 18 over here. It's a much bigger clock. All right. So I'm not going to be able to write every number, but it'd be 1, 2, 3, 4, 5, and then 7, 8, 9, 10, 11. And I said I wasn't going to write them, but I'm 13 all the way to 17, and then 19 all the way to 23. So you'd have a 24-hour clock. Yeah. Now it's cool if you've anybody been in the military. We don't ever say 24. In the military, you say 0, or you say 0 hours. Yeah, or some people say 0 hours or something like that to make it look like an actual clock. But essentially, the military already uses this concept. And I think the reason is obvious. If you say, okay, we're going to attack at 6 o'clock, and half your army wants to attack at 6 a.m. and the other half wants to attack at 6 p.m., you want to make sure that you're going to all be doing whatever you're doing at the same time. Otherwise, things could go very badly. So in the military, if you say 600 hours or 6 o'clock, you literally mean 6. You don't mean 6 p.m. because that would be over here at 18. All right, and so the way the military clock works is you have your AM is over on this side, and you have your PM is on this side. So what we're going to do is we're going to do mod 24. So we've got 150 hours is what mod 24? Okay. Don't worry about the 3 p.m. right now. We're going to wait until we're done solving our modulus. Then we can go back and look at what happens at 3 o'clock. Okay, let's first figure out what 150 hours is, mod 24. All right, so we're going to divide, and then we're going to put the remainder right here. So 150 divided by 24. Again, don't use your calculator because your calculator will just give you a decimal. All right, so 24 goes into 150, I don't know, 5, 6, 7 times. I'm just guessing. I could always change my mind. 7 times 4 is 28, carry the 2. 7 times 2 is 14, plus 2 is 6. Oh, it's too big. So guess again, 6 times. 6 times 4 is 24, carry the 2. 6 times 2 is 12, plus 2 is 14. Just right. Remainder 6. You always want to put the remainder up here. Okay. So 150 hours, mod 24, acts like 6 hours. So that means if we started at 3 p.m., 3 p.m. would be over here, p.m. So this would be 12 is noon, 13 is 1, 14 is 2, so 15 is 3 p.m., 1,500 hours is, or 15 o'clock, you could call it. It's the same as 3 p.m. And then you're going to add 6 hours to that. So you're going to go 3 p.m. plus 6 hours equals 9 p.m. So that would be our answer. 9 p.m. on a military clock is 21. I'm adding 6 hours. I'm adding 6 hours to 15, and that's how I get my 21. Now, I don't want the answer in military time. In military time, you'd say 2,100 hours, sir. But I want you to say it in civilian time, so 2,100 hours is 9 p.m. Had I landed over on this side, then I would say 9 a.m. But I didn't. I was over here in the PM side. So make sure you keep your AMs and your PMs separate. Okay, so that's clock arithmetic. That's the motivating example. Another thing that's a lot like a clock is a calendar. In fact, a calendar is a type of clock. You can really think of a calendar as a paper clock. Example 3. If today is Tuesday, what day will it be in 200 days? So I've got Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and Monday. So this is what we call mod 7. Yeah, there are 7 days. Today is Tuesday. Yeah. So 7 will act like 0. Yeah, and then 1, 2, 3, 4, 5, 6. Every 7 days, I'll be back to Tuesday. Yeah, and it's just going to go around and around and around and around and around. And you don't even have to worry about leap years, because even in a leap year, you still add the day of the week. We don't skip a day of the week or jump ahead a day of the week. It's still going to be the next day. So it's always 7, 7, 7, 7, 7. So we want to know, what is 200 equal to mod 7? Or what is 200 congruent to? Sometimes we just say equal when we really mean congruent. In other words, what does 200 days act like? It's got to be one of these, yeah? If it comes out to be 0, then we say it's Tuesday. If it comes out to be 1, we say it's Wednesday. So just whichever number it comes out to be, that's where we end up. All right, so remember, you divide, and you put the remainder in here, divide by the modulus. So 200 divided by 7, that would be 20 divided by 7 is 2. 2 times 7 is 14, remainder 6, bring down the 0. 7 goes into 60 8 times. 8 times 7 is 56, remainder 4. So that means 20 is behaving like 4. It also means, if you want to check your answer, 200 minus 4 should be divisible by 7. Uh, 196 divides by 7 exactly 28 times. Yep. This part you actually can do on your calculator, because you're not going to get a decimal, you're not going to get a remainder. It should come out exact. In fact, if you do get a decimal, then that means you did something wrong over here. All right. So it acts like 4. So 200 days on a modulo 7 calendar is only going to act like 4 days. So what day will it be? It'll be Saturday. Because 200 days is essentially going to act like 4 days. Example 4. Find the values which make the congruences true. Just to practice the mod 7s. So 7. Well, 7 is divisible by 7, so the remainder is 0. This essentially means that 7 is congruent to 0, so it acts like 0. It's kind of like saying, if today's Tuesday, what day is it going to be 7 days from now? Well, it's still going to be Tuesday because it's acting like nothing. Well, then 8 is going to act like 1. 9 is going to act like 2, be congruent to 2. And 10 is going to be congruent to 3. You could continue this pattern. By the time you get to 14, you'll be back at 0 again. So one pattern that you'll notice with the modulus is every multiple of the modulus acts like nothing. It acts like 0. Keep that in mind. Okay, so now I'm just going to dive into different moduluses and practicing the calculations without any real word problem applications for any of these problems. We're just going to do some fun potpourri math, just a mixture of different flowers. All right, so I'm just going to use a simple instruction, complete the congruences. I think it's clear that I want you to make them all true. I'm not going to ask you for any false statements. What is 17 congruent to mod 5? So no particular application, just the modulus tells you what you're dividing by. All right. Most of these you can do in your head. So 17 divided by 5. Here, I'll do the mental math. 17 divided by 5 is 3, remainder 2. So 17 would act like 2. Uh, 23 modulo 8. What's 23 going to act like modulo 8? So again, how many 8s go into 23? Well, 2. 2 8s, yeah? Remainder 7. And again, I'll do the mental math here. 23 divided by 8 is 2. Remainder 7. Yeah, 2 times 8 is 16. 23 minus 16 is 7. $54, what's that equal to or congruent to modulo 10? 10s are easy because you probably memorized all your 10s when you were little. I hope you memorized all your 10s when you were little. So how many 10s go into 50? I don't even have to ask, do I? 5 10s, and the remainder is 4. So modulo 10 will be one of the easier moduluses. It kind of makes you wonder, why don't we make clocks 10? And I'll refer you to your history class. The French Revolution, they tried to make a clock 10. It was a pretty good idea, but it didn't go down very well. What is 96 congruent to modulo 15? We're getting a little trickier now. Dividing by 15 is not really something I think that you would do immediately in your head, so definitely write this one down. These other ones you probably could have done without the bubbles. 15 goes into 96. How many times? I don't know. Just guess. 5 times? Maybe 6 times? 5's a little shy. 7's too much. Remember Goldilocks? Just right. 6 times 5 is 30. Carry the 3. 6 times 1 plus 3 is 9. Just right. Remainder 6. So 96 acts like 6. It's congruent to 6. Okay, 2,200 mod 20. All right, so you got 2,200 mod 20. You're going to divide by the modulus. One times 20 is 20, and then bring down the 0. 20 goes into 20 one time. Bring down another 0. So it's 110 exactly. No remainder. If there is no remainder, then, and the modulus divides evenly with no remainder, then that means it is congruent to 0. Okay. Next, we're going to talk about negative numbers. Okay, so negative numbers. Now, keep in mind, positives go clockwise. Negatives go counterclockwise. The modulus is telling you who acts like 0. So 8 is like 0. Yeah. So we're essentially going like this. 0, 1, 2, 3, 4, 5, 6, 7, and then back to 0 again. So this acts like 0. 8 acts like 0. So positives are going to go this way. Negatives are going to go this way. So we have -5. So we're going to go counterclockwise. 5 units. So -1, -2, -3, -4, -5. So it is congruent to 3. With negative numbers, you can't divide because you're not going to be able to divide -5 divided by 8. It's just not going to work out for you. Okay, you should still check your answer. -5 minus 3 should be divisible by 8. Is it? Yeah, -5 minus 3 is -8. Yeah, -8 divided by 8 is -1. Check. There's no remainder. With no remainder. I'll go ahead and stop now. Take a break. Okay, so we're up to example 7. Again, finding the congruence for the given modulus. Our modulus is mod 10, and the congruence is the 3-bar equal sign here. We want to find what value is equivalent or congruent to -98. All right. Now, if this was a smaller number, like -8 or -5, or something less, between 0 and -10, then I would just go around counterclockwise on the clock, and I would say, okay, 0 is like 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, if you have a negative, you would go like this. If it's less than 10, if this value is less than 10. All right, so negatives would go that way, and positives would go this way. Okay. In this particular example, we don't have a positive, we have a negative, so we're going to be going counterclockwise. But first we have to divide by the modulus, which is 10. So we have negative 98 divided by 10. I don't know if you've ever divided negative numbers using long division. You just bring the negative up here. Yeah, just bring the negative sign up here and treat it like ordinary division. So I've got 10 goes into 98 9 times. 9 times 10 is 90. So my remainder is 8. Yeah. So we say 9 times 10, negative 9 times 10 minus 8. Yeah. So again, this is the modulus. Negative 9 times 10. Yeah. And then negative 8 is the remainder. Okay. So we're going to go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So we're going around counterclockwise until we get to negative 8. And so that tells me the answer is 2. You could write this out in steps if you like. Negative 98 is congruent to negative 8. Negative 8 is congruent to 2 mod 10, if you like to do it in steps. Okay, so we've seen positive numbers going clockwise, negative numbers going counterclockwise. Now we're ready to do arithmetic with modulus. So this is sometimes called modular arithmetic. Let's start off with something simple, addition. So 14 plus 15 mod 9. Okay. So 14 plus 15 is 29. But 29 is larger than 9. So we have to divide it and look for the remainder. 9 goes into 29 3 times. 3 times 9 is 27. Remainder 2. So 29 is equal to 2 mod 9. How about 5 minus 18 mod 6? All right, 5 minus 18 is negative 13. Negative 13 has an absolute value that's larger than 6. In fact, I just ignore the negative when I'm doing my calculation. So again, we're going to do 13, or negative 13 divided by 6. So that's, you ignore the negative. 6 goes into 13 2 times. Just bring the negative up. Negative 2 times 6 is negative 12. Again, ignoring the negative, your remainder is 1. All right, or negative 1 if you think of it as a negative. Essentially what this means is negative 13 is negative 2 times 6 plus negative 1. Yeah. This is the remainder. So negative 13 acts like negative 1. Yeah, because it's divisible by 6 plus negative 1. And again, mod 6. Yeah. So you could draw the little circle if you want. Remember, 6 acts like 0. 1, 2, 3, 4, 5, and then you're back to 6. Yeah, so negative 1 means go counterclockwise. So negative 1 is 1 space away from 0. So that will be 5. So just go back to the original problem here. 5 minus 18 is 5 mod 6. One way to think about this is 18 is a multiple of 6. So now that you've done the problem, 18 is acting like 0. Yeah. So you end up with 5 minus nothing. Yeah, so 18 acts like nothing. How about some multiplication? Going through everything except division. You're going to use division to solve a lot of these problems, but we're not going to actually divide our moduluses. So how about this one? 23 times 12 mod 7. There are actually 2 ways to solve this problem. One way is the hard way. You actually have to multiply 23 times 12. You can use a calculator if you want for this. So you get 276 mod 7. Then you have to divide by 7. Divided by 7. So that's going to give you 3. 3 times 7 is 21. 7 goes into 66 9 times. Remainder 3. So you could do it that way. All right. This is what I call the hard way. It might not be so hard for you. You might say, really, Dr. Jordan, you're calling that the hard way? Well, yeah, I'm calling it the harder way. There is an easier way. Okay. Why bother multiplying these numbers and getting a huge number when you're just going to divide it out anyway? So there is an easier way. Keep in mind the answer is 3. Let's see a different way to do it. The easy way. What is 23 modulo 7? Well, 23 is equal to 2. Yeah. Remember, 23 divided by 7 is 3, remainder 2. So when we're doing our modulo 7, we just look at the remainder when you divide by 7. Right? And then 12 is equal to 5. Yeah. 7 goes into 12 one time. 1 times 7. And you get the remainder of 5. And again, I think you probably, I don't think there's anybody in my class that couldn't have just done those calculations mentally, especially with numbers like 23 and 12. When the numbers start to get into the hundreds and the thousands, then work is going to be much more important. So the easy way to do it is to turn your 23 into 2, turn your 12 into 5, multiply 2 times 5, you get 10. And now you could do it all with mental math. 10 divided by 7, all I care about is the remainder. What's the remainder? 3. And so that's your easier way to do it. You should still get the same answer, whether you do it the easy way or whether you do it the hard way. Okay. So suppose I'm doing a bunch of numbers. 10 times 12 times 14. I'll start with 3 numbers. We'll get up a little bit higher. And I want to do this mod 6. When you see more than 2 numbers, I recommend doing it the easy way, the way that I mentioned, where you think of each number individually. 10, if you think of it mod 6, 10 acts like 4. Yeah. Again, just do mental math. 10 divided by 6 is 1. We don't care about the 1. We only care about the remainder. The remainder is 4. 12 divided by 6 is 2 with no remainder. So the remainder is 0. So 12 acts like 0. And then 14 divided by 6 is 2 with a remainder of 2. So you have 4 times 0 times 2. Remember, these are multiplications, not decimals. These are multiplications. We're not doing any decimals in this section. So this comes out to be 0. 0 is just equal to 0. Yeah. So the answer is 0. If any of these numbers are a multiple of the modulus, you will always get 0. All right? So that saves you a little bit of time. So if you see a big problem with lots of numbers, look to see if any of those numbers are a multiple of the modulus, and then you will automatically be able to calculate the value. Sometimes you don't get lucky, you get something like this. In this case, they're all odd numbers that we're multiplying. None of these are multiples of 2. None of these are multiples of 2. All right, so none of them are going to be 0. So it's not going to be 0. So you're not going to get a free answer on this one. So in this case, let's just do each one. All right, 1. 1 is just equal to 1. Anything smaller than the modulus is just equal to whatever it is. 3. Well, 3 is equal to 1. Yeah. When you divide it by 2, the remainder is 1. 5 is equal to 1. Yeah. In fact, these are all going to be equal to 1 if you're doing modulo 2. 7 is equal to 1. 9 is equal to 1. And 11 is equal to 1. So this literally says 1 times 1 times 1 times 1 times 1 times 1, which is equal to 1 mod 2. So the answer is 1. Okay, the last thing I want to talk about, example 12, is a factorial. Maybe you've seen these before. This is called a factorial. It means to multiply by all the whole numbers less than 8. It's not always going to be 8. It's whatever this value happens to be. We call it n, whatever this n happens to be. So that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whole numbers only. Actually, I should probably rephrase that. Whole is a bad way to say that. I should probably use the proper name. Natural numbers. Natural numbers stop with 1. So I have to make small correction. I said whole when I really meant to say natural. Minor detail. Okay, so if any of these numbers are a multiple of 9, you get a free answer. It's going to be 0. Automatically 0. Unfortunately, none of these are a multiple of 9. Yeah. Now, let's watch this very carefully, though. We can do them 2 at a time. So 8 times 7 is 56. Yeah. 56 divided by 9 is 54, right? 54 goes into 56 one time. Yeah. So let's do it out. 56 divided by 9 would be 6. There's your 54. Remainder 2. So that means 56 becomes 2. Okay. How about 6 times 5? 6 times 5 is 30. 30 divided by 9, 27. Remainder 3. So 30 becomes 3. And just keep doing them 2 at a time. 4 times 3 is 12. If you want to take a bigger bite, you can do more than 2. I just think 2 is a nice way to start. 4 times 3 is 12. You can probably do that one in your head. 12 divided by 9. Only care about the remainder. The remainder is 3. 2 times 1 is 2. 2 is less than 9, so 2 stays a 2. So you don't really want to multiply all these numbers together. If you do, you're going to get a really big number, and you might regret it. So just do them in pairs. And now 2 times 3 is 6. 6 times 3 is 18. 18 times 2 is 36. 36 is now a multiple of 9. So 36 is equal to 0 mod 9. So notice that none of these numbers were actually equal to 9, but when I multiplied them all out, I got 36, and 36 is a multiple of 9. So every multiple of 9 is essentially like 0. Okay? I will briefly review this tomorrow, but tomorrow we're going to focus on the applications of the modular arithmetic. So I'll do a brief review of the rundown, see how you guys are doing on your homework. If you have any questions, you can log into the office hours. So, Dr. Jordan signing out.